My name is Shaaf. I'm a developer advocate at Red Hat. I've worked with large language models, fine-tuning, etc. And I'm going to talk about how we're doing things with LangChain4j.
I'm Bazlur, and I work for a company called Devnexus. I'm a senior software engineer. Actually, I'm a staff software developer. I have got from that. Anyway, all right, I switched from last company to this company, so they have given me a title. Anyway, so yeah, I'm also a Java champion, and yeah, that's about me. And we're gonna talk about LLMs apps in Java with LangChain4j and JakartaEE. So we have a lot of demo, but Shaaf will start some initial discussion, and we all want your participation as well. So it's going to be interactive, demo-driven.
So, so I have 300 slides for you to just get started. And obviously, we want to talk about large language models. We want to talk about how it fits with Java. And we've chosen LangChain4j and JakartaEE for the reason that if you use Spring AI, if you use Quarkus, LangChain4j extension, etc., it has all these nice things, and it's great. But what we want to focus in this talk is give you a flavor of when you're doing these things, how are you looking at the different aspects, how are you building it, and we'll start with the basic chatbot, etc. So I don't want to take more time than 10 minutes because Bazlur is standing right behind me. I can't present. I used to be in sales, pre-sales before, so I can talk a lot, so I'll try to stop. But getting onto context, when we talk about systems, data, network, there's a lot of data that's out there. And today, when we build systems in a more structured format. All the data that is out there is in your database. It's perhaps coming from your events, and you're trying to put structure to it so you actually can use it. When you come to natural language processing, kind of changes the game, right? When you go and ask a large language model, you ask a simple question, you ask in plain English. You don't ask it with a select query or something like that, right? So it kind of changes the way we deal with this sort of scenario when we work with large language models, because now to express ourselves and what we want to get out of the system, in this case the large language model, we need to express it in English, right? So we'll go through some of these scenarios, like how we've been learning this, and obviously we're still learning. So hopefully you will be able to join us on that journey, right? Also, from a data perspective, if we look at just organizations in general, we have systems that are rigid, systems that have rules, and systems that are in place. But what happens when there's a lot of data that comes in, right? Like GPT-3 I believe, was trained on 300 billion tokens, and 450 on the other one, etc. So it kind of goes up to these gigabytes and terabytes of data that you need to get, which is all unstructured. And that unstructured data then forms that entire training base of a large language model, and then you invoke it with that. So even with all the systems, IoT, all the data that you're getting from your systems in your environments, you might have seen that there's a lot of unstructured data that you're experiencing at this moment. How do you actually leverage that? Are you going to just structure all of that again? And would you have to go through all the process of structuring that data? This doesn't mean that all data needs to be structured, or this doesn't mean that all data seems to be unstructured, right? So I'm not saying that, just to be clear. So obviously the customer the demand is quite high in terms of high in sense that the demand on the systems is high in terms of getting all this data incorporated into our environment. And then when somebody goes to GPT and says, hey, give me the next strategy of my company, I hope nobody does that. But anyways, if you ask that, then it will start giving you these nice things that any person would look at and say, hey, I also want this. I want to do exactly the same thing. So how do we actually bring this? What we will cover in this talk is what are those pitfalls, what are those areas, what you should be careful. For example, if you write a prompt for one large language model, the guarantee that that prompt is going to have the same result on another large language model is not there. And funnily enough, it's not even there if you try to do the same prompt again on the same large language model, right? So there's some things that we are not adhered to as Java developers. And what can we do to do that? Then also going a little bit in history, just to give you some context about how the whole large language model journey comes into place, right? So I did a course on expert system, and it was extremely boring back then. Well, in a way. It was hard to work with. The use of data was difficult. We had to do these different routines, but the concept of neural networks back then was not like, it wasn't as easy and simple as it is today. But when we went into something like machine learning and we started experiencing tensors and all of these different aspects where you could grow your neural network, the technology completely changed roughly around 2000s, right? And deep learning came into play where you could actually help your models learn more as they go along. These things obviously were not there when Java was invented and when Java started to look at these things. And obviously, Python has a lot of share when it comes to predictive AI, training model, using the hardware, et cetera, all these things. But large language models, if I was to say this today, the best suitable language, in my view, is Java to use with large language models. You don't want to train large language models with Java, but when it comes to the way Java works with these systems, whether it's threading, whether it's the way we express ourselves when we write the code, Java is a much suitable language to work with large language models. And so finally, we come to foundational models, and foundational models obviously are what we talk about, or Stanford mentioned, I think somewhere around 2011, that you have these models which we come to know as large language models today that does natural language processing. Now, this natural language processing comes from a very, very simplistic view of the world. You can convert German language to English and English to German. Well, don't try Google Translate for that. I can tell you it's going to completely change the meaning of things. But the transformer pattern that Google came out with, which actually does this, is translating one language form to another, right? So it's pure natural language processing, and that's what the paper, it's called Attention is All You Need. It has a transformer architecture, and that's how the large language model was built on. And it has a lot of billions of words or tokens or things that you have heard these words before that you would do. And maybe I'll ask this question: how many of you actively use large language models today? Okay, and how many of you want to use them in the future? Okay, so it's like growing. I can see the growth. So hopefully I'm able to explain this in a way that it helps you to understand that what large language models are and how you can use them, right? So in any ways, there's a bunch of large language models that are out there. And GPT is not the only one. And when you look at private AI cases, or you want to run something locally, you want to have models with different sizes. There are billions of parameters on them, and they have a lot of these training processes. But as Java developers, when I used to write Java applications many, many years ago, I never cared how it was deployed, to be honest. Now, that's just a confession here. But anyways, I thought, okay, it's the ops guys who's going to take care of it. Who cares what goes under, right? So pretty similarly, large language models, they can be trained with Python. They can be done. And if it's something of your interest to go into that, you should go in. But using them and using the way they are created, it would be amazing that we could do that with Java as an example, right? So that's the whole point. We're going to use this word, things like tokens, a lot. So what are tokens? And I'm sure you have heard about tokens. Anybody's heard about tokens before? So people who use APIs would say, oh, I'm running out of tokens, right? And that's very normal. And then you just pull them up, and then you do something for the whole night, and the tokens are gone again, right? So, but what tokens do is, tokens is the way that we work with large language models. Inside them, they're also using it in terms of algorithms, because we have plain English, but that plain English and then just translate it into specific, vector embeddings as an example. So there's tokens, that is the unit of measurement of how you are actually interacting with a large language model. The input you send to a large language model is tokens. The output you get from a large language model is tokens. So that's how it works. But what works behind the scene is the embeddings, which optimize. And you probably have heard this word embeddings as well in some of these talks today, right? And the embeddings will make it into a numerical format. And that numerical format, all the numerical format, and that's what I want you to remember, does is the similarity search, right? So it checks that what you've asked for, do I have this locally, that I can actually pass this to the large language model? That large language model will say, hey, okay, it makes sense to me as well, right? So that's what it is on the most basic level. So there's some nice articles, some nice algorithms that I point out, but I also point out a book which is not for marketing for this guy, but it's a really nice book which is about building large language model from scratch. If you want to get into the theory of it, you can definitely get in there. Another interesting thing is that, this is an amazing picture, and I don't know if you've noticed, is that the girl doesn't have, all the fingers on the hand. And amazing things, but stupid mistakes, right? And stupid mistakes, why? Because do not mix accuracy with truth. I mean, that's a very important takeaway for this. They are accurate, they are predictive, large language models can do things, but they not necessarily are giving you the truth. And hopefully in this demo today, if I get to my part as well, I can show you that, how much lies we can spit, right? So the default at the end of it is obviously that you have to think that the large language models will not give you what you want. So how are you going to deal with it, right? And we're going to talk about that. Finally, truth is discrete, it's not continuous, right? So when we talk about, somebody's, there's 7 lives saved by this doctor, or 700 lives saved by a doctor, we never say 7.5 lives saved, right? Because there is nothing like a half life. It is specific, it is that number that doesn't change. So it's not continuous, it not keeps on changing all the time, it is specific, and that's what we also need to remember when we are using large language models, and that can also happen. And finally, this is meant to scare you, right? Because this is what we hear every time, like people are talking about embeddings, transformers, attention, guardrails, privacy, et cetera, all these things. So you will still be scared by the end of this talk, just so I tell you, right? So finally, we're going to use LangChain4j. LangChain4j is an awesome Java library that helps you do it. Quarkus has an extension to it. JakartaEE can use it. There's small Rye, LLM sort of stuff over there. So there's a lot of word, and I think LangChain4j in that sense, I would say, is one of the best libraries that's out there to use. It helps you to do LLM integration, prompt engineering, RAG tools, etc. All of these things, and we're going to cover some of these today. If I actually stop presenting, then Bazlur can actually show something. So I'm going to stop here, and I'm going to hand over to you, and you can show something, and then I can come back.
You will stay here.
I'll try to stay here. Yeah, I'll just be behind you. Yeah. Yeah, you probably need a mic.
So this.
Take the mic. Yeah.
So like I said, it's going to be demo driven, right? And we chose to implement this demo with JakartaEE. And if you are scared of JakartaEE, is there anyone who is scared of JakartaEE? Or do you use JakartaEE at all? I mean, it's an important technology, right? It's an important, and many of other technologies use the standard of JakartaEE, right? So we should appreciate that. Anyway, so there is a nice JakartaEE project generator. You can use it for generating Jakarta projects. So this is how we started for this demo. So we created a project from here. We selected our Jakarta version, Jakarta profile, Java versions, and all of those things. And when we click over here, it gives us a nice project structure that where we can start out putting our own code basically. So that's how we started, and I have already prepared all of those things. So I just want to cut the time of demo, so I don't want to go through the same process again. So over here, let me just close all of those things. Close other tabs, this one also. So I have over here, basically we created a multi-step projects. We have like over here 8. So the idea is we'll start with basics, and then we'll advance as we go on, add new stuff, new features of LangChain4j and integration with the JakartaEE. And the very basic one, which is we're gonna do a chat bot. So we can talk to a LLM through Java basically. And then on top of that, we'll keep on adding stuff. So very basics, basic one is basically this class. You can see the code from behind, or should I, increase font a bit? So over here, as you can see, we have used the open AI chat model. It's a class, given by the LangChain4j. It's a pretty basic class. What you do over here is you just instantiate with a bunch of argument parameters. You can skip some of those things. For example, I can pretty much skip for the basics. I can skip all of these things and it still works. And I can send a text and it will respond me a text. So the reason I added those because I want to show you something. There's certain parameters which I'm going to explain. The idea is we created chat models and we pass the API key. We're using ChatGPT OpenAI API over here, but we can definitely use any other API similarly. Interestingly, this library support other LLMs. For example, this library supports, the Gemini also support the, I think, Anthropic one API also this supported by this OpenAI chat model. This is becoming the kind of the standard API right now, and so every other LLMs kind of adding their support on this particular interface, I would say. So you can add try with other LLMs as well. So that's all. And since we're using JakartaEE and we want to do a chatbot, so what we did is we have a WebSocket, and creating WebSocket using JakartaEE is pretty easy. You can just write a class and say it's a WebSocket with the annotation over here, and then you do some front-end logics. So I'm not going to explain all of those things, but let's show you the demo what it is. So this is the chat interface. So basically over here we can write whatever we want to write, and then it will respond. It will communicate to the chat. It will communicate with the OpenAI API for a specific model. We specified that as well. So anyone want to volunteer? Like I can give me a prompt. Ask me something. We can say something like why. It's always rainy in Atlanta. Let's see what it returns. So basically, this is a basic version of LLMs. All you need is this one class over here. So LangChain for service, and that's all. Basically, other on top of the, we are doing the, we have an interface over here, which is basically based on Jakarta faces and some, JavaScript magic, and also some CSS tricks, which is generated by a ChatGPT as well. So, and no credit over here. So this is, so when we created chat model over here, and then we send a message to it, chat model generate, and it returns a text to us. And that's what we basically show over here. As you can see, it's returned some information basically. Now over here, this is a basic version of our API, but we can configure in a way. There are certain parameters that we can configure. For example, you saw a bunch of parameters I added, right? One of these are basically called temperature. And there are other ones. For example, over here I mentioned max token. So Shaaf already shared about what is token it means. So the idea is if I mention max token, the idea is the whole conversation will use maximum this many tokens. So if I add like let's say 10, and it will try to limit our conversation 10 token, but it will probably not a complete conversation because how much you can communicate with the 10 tokens, right? So that's the idea. And the temperature is basically how we control the randomness. If it is low, like over here 0.2, then it will be less random. But if we increase it like a large number, let's say 0.7, then it will add more, randomness to it. So it will be more creative, unique, all those things. So there are other parameters over here. We can definitely experiment with this, but we have so many other interesting demo, so I want to skip this part, but that's the basic idea. You can look it up. And we have a nice repository over here, and we have like 8 steps. It's kind of, we designed in a workshop way. So you start with the first one, and you will do some experiment, and then go next one. You'll do some advanced stuff, and then you will get to the advanced, which is Shaaf is gonna share with us. So I have to keep in mind about my timing because we have lots of demo to show you. All right. So the problem is that since we designed in a way, it's easier, but at the same time it creates some problem, which is I have to restart again. So go to the next step.
So what you've seen here right now is just basic chat, right? I'm sure you kind of understand that. You could go on GPT and type something and it's just going to give you answers. But what now we're going to do is that we're going to add some prompts. So we're going to do some prompt engineering with the same sort of chat style, so you can actually see how that affects. Like we'll have different personalities of prompts, and we'll go through that. And you can join in as well if you want us to ask a question, I'm sure.
So these are our basic prompts, and we are going to talk about a bit about AI services. The idea is, before showing the prompt, I'm going to talk a little bit. So these LangChain 4J provides us a way of injecting prompts, and the way you guys familiar with the Spring Data, right? You specify your intent, and it does everything. Like it does all the abstraction under the hood. So AI service is basically like that. You specify your prompt. Like there's two kinds of prompt that we can specify, which is system prompts, like the behavior of the chat engine, and then you can pass user prompt as much as you can. So that's the idea. Do you know?
Yeah, go ahead. I think. Probably start it up and
yeah. So then we're going to talk about a few prompts. So let's show you the code first, because I like to work with the code rather than slides. So over here we have a different kind of prompts. For example, there is a prompt called called Java Champion. It's a funny prompt, as you can see over here, and I'm sad that we are not using text block over here. All right.
So here it's a system prompt, right? So the system prompt is sort of telling the large language model how it should behave, how it should respond. So you could even say like, oh, do not give me an answer more than 2 lines, and then the system prompt will control that when the response comes out, right? So that's pretty much what we're doing. We're giving a Java champion a profile of a sarcastic sense of humor. So maybe let's try ask a question and see how that responds, and then we can understand what's actually going on.
Okay, before going that, I'm just gonna show you that additional thing we did over here, apart from the previous configurations. So over here we have this the chat model. That this is we using the builder pattern. We instantiate it. It's a bit different over here. It's a streaming service, same thing, but instead of sending the whole thing at once, it's stream. So it sends a token I guess 1 token at a time, right? Yeah. So it keeps on sending things. It became, if it's the answer is long and you don't see anything on the screen, it's frustrating, right? But if it's keep on sending, you are seeing, as you also reading it gives a kind of responsiveness.
So the response is streamed, right? Not the request.
No, response is streamed. Yeah. Response is streamed. Okay, so over here it's the same thing, but with the AI services, we can. We have multiple over here. So we create something like that. There is a class called AI services. It has a builder pattern. It takes the interface, which is I showed you Java Champion interface. Since we have multiple over here, we kind of generalize it. And then we provide a chat language model that we instantiate earlier, and we build it. And then we talk with that particular interface. That's all. So it's a whole abstraction like Spring Data and Jakarta Data. I think you already know. So let's see the demo over here. Okay. So where's the? So I'm going to refresh this page a bit. So I think there is a little bit conflict that I need to refresh the cache, but yeah, that's all. As you can see over here, we have multiple we have multiple prompts. We can choose. So we're going to start with the Java Champion.
Do I want to say something?
Yeah. Or anyone, if you want to say something too.
Do you have a question?
Yes. Do you use JakartaEE or Spring Boot?
We're using Jakarta.
That's the question he's asking. That's the question.
Oh, sorry. Can you repeat the question? I didn't hear.
Should I use JakartaEE or Spring Boot?
Okay, should I
Why are you using JakartaEE if you're using Spring Boot?
or Spring Boot? Okay, let's see what it says. Okay. All these questions, Jakarta or Spring. And I mean, it's sent some response, right? You can read it. I'm not gonna read it, but what interesting at the
Classical rock band and latest pop sensation, like that's awesome. Right?
what I'm gonna focus on here is at the last line. As you can see, it says I'm the real champion. So the reason it's saying is when we specified our Java champion, prompts, as you can see at the last, I said always respond at the end with "I'm the real champion." So that respected that. So that's the prompt. We have a few other. Do you want to try any other prompt? Any other question? We can move on.
Why do we need a singleton?
Oh, okay. That's an interesting question. Why do we need a singleton? Okay. I mean, if I spell some word wrong, it can fix it because it's AI, right? So, okay. So it says, "Oh, singleton pattern." You guys read it. So it's basically a sarcastic, prompt. We define that way. And if we have some
Question.
Yeah, why did you put that as part of the user prompt instead of putting it in system prompt?
Okay, that's a good question. Do you want to take that answer?
Yeah, sure.
Yeah. So over here, I'm the real champion. We put in a user prompt.
Actually, we can put that in system prompt. It shouldn't matter in this case. The user prompt is obviously the input of the user at that particular time. The system prompt sets the profile. So yeah, I think
We could do that.
we could do that.
And over here, what we did is we are passing the user prompt into this text basically. So we're saying respond about the topic. Topic basically whatever the question user sends, and add that over here, and then add additional. So basically, as a system prompt, we're saying that, but we could do that using system prompt as well.
Yeah, and it's more like a practice, right? Because it's sort of like we're kind of segmenting mentally that we've set a profile, and then the user prompt is where we're basically talking about the rest of the output. So it's just a practice. Yeah, go ahead.
What's the max tokens? Is it how verbose the responses or how much the input is considered?
So we can say that, okay, don't answer more than five sentences. They are models, and all models behave differently. I'm not going to name a model, but there's a model I asked one question, simple. It gave me a 10-page answer, right? So the models behave differently. So you want to control them, and this is one way, is through prompts telling them, okay, do not respond more than 5 sentences or 5 lines, etc.
All right. Also, I'm going to share a demo in next step, which is there is a thing called context window. I'm going to talk about in a minute, but yeah. So there is other prompt over here, for example, chain of thoughts, tree of thoughts, and something, or many of those. I'm not going to show you because we have others, demo. You guys can just take the source code and try yourself.
Yeah, but maybe show the chain of thought. That would be nice.
Okay.
It's okay, we can take some more time.
Okay. So I think it restarted. I probably have to refresh this page. Yeah, and something it happens. Sorry about that. Okay. So if I, add chain of thoughts, so basically how chain of thoughts work is when we solve a problem, let's say we want to, we asked something like, a multiplication of an equation, right? So it can answer me one step, right? In calculator, it does that, right? But it can also show us how it goes, found that answer. So it shows us the steps of processing. So for example, do you want to give an example?
Yeah, sure. So, I mean, you want to have a question about something?
Yeah.
Yeah, so maybe you can ask the singleton question again, and it will probably give you a more chain of thought on that. So chain of thought is obviously going to give some sort of reasoning, understanding of what the process was to reach to this certain conclusion.
Okay. Why do we need a singleton? Need this singleton. Okay, so let's see what it replies. Oh, the reason, okay, it's streaming. Okay, it's streaming basically. So, I mean, so what it says.
So it's giving you the details. Can you open the prompt? Maybe I think that's easier. So it gives you the details. Let's take a look at prompt that's going to explain more.
Right. So over here, we said the chain of thought. You are the helpful assistant. Always provide concise, professional response when solving problem. Always explain COT reasoning, chain of thought reasoning. So basically, we asked to use that process basically. So if I give it an equation, it will first solve first part. It will divide and then come to a conclusion, something like that.
So think of it like this. Like let's say you gave a code. The JakartaEE code, and then you said, okay, convert that to Spring, right? And while it's converting, it needs to go through this reasoning process. So in such cases, this is a good example where it should actually give you that reasoning, and you should be able to look at it. There's also other methodologies like tree of thought, and maybe you want to the slides there.
So we have others over here. Yeah, a tree of thoughts, and we can basically, the idea is we can specify whatever we want in the system prod, and it will act like that. And that's the highlight, basically.
And in a case like a migration scenario or something like this, or conversion scenario, then you can, if you're developing software, right, you want your user to have some good insight into what actually happened. So that kind of helps in that process as well.
All right, so enough of prompts. We're gonna move to the next one.
Prompts is always the fun part.
So next one is basically going to talk about a bit of memory. The reason memory, what it is basically when we talk to a for example, I'm pretty sure everyone used ChatGPT, Gemini, right? So you start the conversation and then you said something, and then you can reference the previous conversation, right? But that way LLM APIs are designed, they're kind of HTTP protocol, right? Kind of procedural, fire and forget. So you ask the questions, you reply the questions, and then forget. The reason, obviously, scalability and other reasons, but that's how it's designed. So it doesn't remember when we are using LangChain 4J with the API, right? So we have to somehow give a context to the LLMs so that it can remember what we already discussed. So shape memory is something like that. So we start conversation, we store all this conversation in the memory or database, whatever, and then whenever we ask next question, we can put all of these questions to the LLMs again so that it can answer properly. So that's the next process over here. The idea is, for example, if I share my name over here, hello, my name is.
So while you do that, I'll just say this, like, do not compare this with OpenAI, right? Because OpenAI is a system, and when you write something, it saves things, it understands them, remembers them. But when you're using any large language model, locally, you're not going to have that same memory functionality. So here, what we're trying to tell you is, like with LangChain 4J, you have that capability that you can actually inject the memory so it actually remembers.
So sorry about that. Hello, this is Bazlur, and it will reply, with my name, right? And now if I ask what is my name, it can remember. It will remember. You mentioned that your name is Bazlur, right? So you now remember, because we used a thing called memory. So that's the code I'm going to show you quickly, and I'm not going to spend a lot of time over here because we have more fun part.
I just want to make, obviously, one point here is that, I don't know if you know this, but large language models do not have a memory. Right? They don't, so they're totally like stateless in a way. So this is what what helps them to keep the memory in your context. Obviously, it depends on how many tokens you're going to put in your memory, so that also has to be restricted, but yeah, that's what it does.
Right. So over here, we added additional step over here. So basically over here, we are using in memory, but we can also provide, support, put that in our databases, and it will remember. The idea is when we are gonna, over here in this code, we have used database of course, Postgres as well. But if I can show you the log, I'm not sure, it's just too many logs. It's just, it's difficult. Okay, just trust me for this one, and you have the source code, and you can try yourself. So see, the idea is basically whenever we send the next message, for example over here, if I send another message, it will send all of those to the LLM, so that LLM has better context and it can reply that. So that's usually very useful. For example, you were going to a booking service, right? Airplane booking service. You were talking to a chatbot, and if it can remember what you have just said, you have to repeat everything, right? That's a unpleasant experience. But with this memory, we can have those basically same human-to-human conversation style of conversation in the chatbot. So that's
question. Can we save this memory? Can we save?
Yes, we can. We can definitely save this in our databases. In our databases, yes. It can also, for example, you had a conversation and then you came back later. You can pull those information and do this again. So you just have to use databases. In this example, we used PostgreSQL. So yeah, we have like 20 minutes. So I'm gonna go ahead quickly. And the other thing. Fun part is basically function calling. So the idea is LLM can does a lot of things, but it also cannot do a lot of things. For example, if you want to do a calculation, especially complex calculation, it will definitely fail miserably. So what we can do is, we can take this responsibility in our code, and we can specify LLMs that there is a function, there is a method in our code base that needs certain parameters. We can specify that in our code, and LLMs can invoke that. Basically, it doesn't invoke that, our framework does, but it can pass those parameters and and specify that this method we are going to call for this particular conversations. So that's what it is. I'm going to show you a quick demo for that. It's
so most of, like, for example, you have your database, right? You have REST APIs, exposed internal systems. Large language model doesn't have that, right? So with doing tools, you can actually call these APIs, call these extra functions that you might have, or compute functions that large language model is capable of. So tools helps you to do that function calling into other systems, as an example.
So for example, we have a method over here, right? It's not fancy. It does, if you provide a URL, it can fetch that URL and give you the content. And now let's say in the LLMs, in the chatbot, I said, hey, can you fetch the last article of Shaaf he wrote in his blog? I can specify the blog URL. So now LLM will know what to do. Probably not all of LLMs can search, right? ChatGPT can, because it has added functionality, but API probably not. So now, if we add this tool to our tool chain, it will know what to do. So the additional changes that we did over here, we have a we have these new methods, and we can specify as many tools as we want. So we have one over here. So I'm going to show you a demo one by one. So let's start with the demo.
Is it really my side or is it yours?
What is the last article written by Shaaf at his blog, shaaf.dev, right? Is it accurate?
Yes, that's correct. Yes.
Yeah. Hopefully it will be able to face it.
Putting surprise prompts on me right now.
Okay. So you wrote this. Is it true?
Yes, that's true.
Okay, so it was able to face that. So, okay, so what happens underlying, you can see over here, when we're gonna send the request, for example, this is the request, that's not the request. Previous one. So this is the request we did, right?
Yes.
No, not the,
It says my URL.
no, the previous one. Let's see. This one.
It was down. It's at Shaaf.dev. Yeah, that one.
So anyway, so over here, when we are sending requests, it also add all this function. We have 3 tools over here. Basically, I'm going to show you one. I showed one, and it adds all this information to the LLMs, so that LLMs can find appropriate function that needs to call and send us back. So yeah.
And what's happening behind the scene is that when we have provided a tool to the large language model, not necessarily that it's going to call that tool, right? So it depends on what you have asked, that it will call that specific tool as well.
So for example, over here, when we asked to go to Shaaf's website, and basically we have so many functions over here. We had multiple. So it invoked this one. It said that this is the function we need to call. The function name is get web page content, and arguments are this, and we have similar tools in this we specified. So length change for J will then invoke that method with this parameter and then get those content and give it to LLMs. LLM will then do further processing and give us to us. So that's the idea. So we have a few more tools. For example, one I'm really experimenting with the other day. For example, I can ask, hey, can you write a Java code for me, for a merge sort? Let's do simple one. Java code for merge sort algorithm with 10 random numbers. So it can certainly do that. It's streaming. Oh, it's streaming. Okay, sorry about that. It takes some time.
Probably OpenAI didn't like your question.
As you can see, it returns the code, right? Now, what I'm interested in, can it compile it as well? So LLMs will definitely not be able to compile it, right? But our tool can. I mean, I have written that code to compile a Java. If I give a string of a Java file, it can compile that. So I can say, can you compile and run it? Let's see what it happens. So over here, what it's going to do is we can see logs. It's going to be busy over here. So it's doing a lot of things. Yes.
So now the tool is in the request as well, right? The tool to get the web page content is also there, but the LLM knows which tool it is that actually does the compilation. So it's going to call that specific tool.
So like it compiled and ran this code, and it took original array and then it sorted basically.
Can you modify it to call your other tool to get the square root of the sorted array or all the elements in it?
I haven't tried this, but yeah, we could do that if we add additional tools. I think it's basically we can go wild. We can add many tools to support whatever we want to do. So for example, I'm gonna give you a quick example over here. So I showed you this, right? So you can specify the version number and everything it can generate, right? So I have written a tool for particularly this example. It can build the entire project and give it to me. So let me show you that.
And while you do that, there is also something called MCP, the Model Context Protocol. And with that, you can also have agents and tools that you can actually chain and use them as well. We don't have that in the demo today, but that's
okay.
something.
One thing I
but how are the tools tied to process function? Is it inferred by the AI, or is there a prompt given to say this is the realm that this tool handles?
It's the meta information that's given in the tools annotation in the code, and there can be chances when it's not going to be called. Right?
So I was wondering how deterministic is the call.
Yeah, it is not. It's not very friendly sometimes, but it is in a way, depending on the description within the tool that you've given, that LangChain for J will actually be able to embed that.
The specificity of the prompt determine the tool. So use this tool to do this.
Yes. Okay. So if you have two descriptions that are very much matching, you can expect that it's going to call one of them, right? So.
I have a question. So you said can you compile and run it? How did it know it is the context of the earlier?
Because it has memory.
What's that?
Memory, like in previous demo, we're using that over here.
It uses some kind of ID, like a session ID.
Yes, there is a memory ID. There is a thing called memory ID. So you can go through this, repository, will find that. Okay, so let's show this demo, right? Sure, I can generate a JakartaEE project, but it's asking questions like, what version do you like? So what I can do is, what option do we have? Prepare yours. Yeah. So it's giving the options. These are the options I have. So it will ask bunch of questions. So I'm gonna sort it. And what are the defaults? Go with defaults and generate the project. So let's see what it says now. Okay, this is going to take a bit of time because it does a lot of processing. If I show you it's super busy. It's doing a lot of things.
How many tokens?
I don't even know how many tokens I provided for this. I have to check. But as you can see, it's doing a lot of things basically, and it's going to generate with the defaults. But if you don't, if I didn't, mention that go with defaults, it will probably ask more questions because it takes like all these 7 parameters to generate this project. So it would kept on asking those questions.
So if you give 5 parameters and you forgot the 2, is it going to ask you for the 2?
Yes, it's gonna. Let's say I specified 5 and say generate a project, and it will definitely ask me you forgot 2. What are those? So let's see if I have. Yes, it says your Jakarta project has been successfully generated, and they give me a link. And if I click on it, I'll be able to download the project over here. Basically, it's a full structure, the same structure that we showed in the website. And before I leave to my friend Shaaf, I'm going to show you that just quickly how we did it. Specified it. For example, this is the generate methods, right? We all put all this description over here. This is tools. This is what you have to do, and you take all these parameters, right? So it is 7, and we also provided enough description so that LLM understands what parameters needs to do, and yeah. So basically, we specified everything, and then if I miss anything, it will definitely ask questions and get those answer from me, and then generates. So that's interesting. That's how much we can do with the tools. And that was the demo basically. But in real life, probably this is not gonna. We are not gonna use project. We're probably not gonna create project with this chatbot. We'll still go to the start.JakartaEE. But I just wanted to show you a demo that this much we can do.
I like it. I would like to do that. But on the @p annotation here, right? That's the parameters. So what we've done is that we're giving each and every parameter. We could have made all of them as one parameter too, right? But by doing this means that's exactly what we're saying. If you give 5 parameters, which is the @p, if you only fulfill five of those annotations, then it will ask you for the 2 that you haven't, right? And vice versa. So that's pretty good. Okay, so
sorry, I ate a lot of time of yours, but good luck for
RAG is the most
good luck for you.
Part. So. Okay. So how many of you are familiar with retrieval augmented generation? Somewhat. Okay. then this is the shortest 10 minutes, I guess, we probably get to learn about something. But okay, so let me just put this slide quickly. So, so you saw on the what we did. We did so we kind of taken this step-by-step approach, right? So we made the chatbot, very basic chatbot, right, and nothing in it. But then we went into system prompt. We defined the system prompt. We defined a user prompt. We went into the tools and injected that into the AI service, right? So that's what we've basically done up till now. What we want to do also is that, okay, we have all these cool things. Yeah, thanks, I forget. So,
I don't know what happened. Sorry for it.
you remind me of my mom, but it's okay. So,
Talking to?
Yeah.
Okay, then we have a second one.
so basically,
Thank you.
what we want to do now is obviously we have all these nice things. You're able to call these APIs tools that are inside, let's say, your environment. What we also want to do is make sure that we can also use the data that we have inside an organization. And that data is important. So that's where the retrieval augmented generation comes in, is that there's a technique where we are going to use an ingestion mechanism, which you see on the top on the corner. You have documents that those documents are ingested. They are embedded, converted into vectors. So they have certain, certain numerical values. And the way, if you remember in the beginning, I said that all about this is what is similarity searching. So we convert them into numerical values so we can actually search them more efficiently and actually send them to the large language model. So like I said, it's going to be the shortest 10-minute RAG demo ever, and I'm going to try to keep up with it, and I'm going to show you how we're doing it. So I'm going to go back to the same thing. I have a document. It's an extremely, extremely important document that I have. Let me see, my mouse is a bit, yeah. So it's the most extremely important document I have in the organization. It is about the ruthless, toothless Java syndicate of Devnexus. It has 30 people like Null Pointer Nick, people like Lambda Lisa, Spring Boot Sally and stuff like that, right? So it's the most secretive thing that exists in my organization. It's a RAG document. It is in a markdown format, in an MD format. And what I'm going to do is that I will use LangChain4j, convert this document into vector embeddings, store this in the PG vector store, and then every time the LLM is going to request, it's going to give me some answers, right? So what I've done basically is that I have my specific startup bean here, and what I'm using right now, I think hopefully I can share more, but I'm using the most simplistic approach of a RAG within LangChain4j, which is called EasyRAG. What EasyRAG does is that it doesn't let you bother about how the segmentation works, how you actually split the documents and text, etc. And I'm pretty sure I'm going to run out of time right now, but so I'm able to talk to you after this as well and demo this further if you need to, right? So what we do here, obviously, let me just go back here. I have a JakartaEE agent. This agent is saying you are a personality expert, and so I'm not a native English speaker, so you can see my mistakes here. I will ask you about a person, and you will tell me who they are in less than one sentence. If you do not recognize them, you will say, I do not know who this is, try again, right? So what I'm doing is, what I've done is that I'm going to split the documents. I'm going to ingest the documents. The documents will go in the PG vector store embedded. And then I've crafted a prompt that is specifically, in my case, the prompt is just talking about personalities, right? That's what it's doing. So that's the very, very simple case. Let me show you. What I'll do is that here, for example, I can see if my embeddings are coming. My machine is coming up. Hopefully it will come up. Total documents parsed, 1, so it's actually able to pick up the document. And hopefully it is also by now done the embeddings. Now, embeddings don't look like this. This is the text. This is the text segment that I've given, right? And what it's done is that it's taken the entire segment. Now, why does it do that? Is because if I go into my bean here again, I have sort of just ran the most basic thing. So it's just doing is just taking what it has in terms of the defaults right now, right? Obviously, I want to change that, but this is how my text looks like. But do you want to see how the embeddings look like? So let's go and do that. So we go into the embedding store, select show data. So here you see that all these numerical values that you see here are the actual vector embeddings that are generated by an embedded model. So, so in this case, obviously, if I go in and ask my awesome JakartaEE bot, I'm really playing with its thought and say, who is AI Alex, right?
You can do full screen.
Oh, yeah. Can you see it?
You can just do full screen though.
Okay, yes. Anyways, so AI Alex is a member of the Ruthless Toothless Syndicate who is trying to replace himself with an AI that codes in Java, right? That's what we're all talking about this week. So anyways, so, so it's sort of able to get that because it is in this chunk that I mentioned, it has actually taken the entire markdown file. What happens when you are doing this? Why would you do this, right? So I want to do something different, and I'm just going to copy code here. Usually I would have tried to just fly by this, but what I'll do here is that I'm going to convert this. And now what I do is I use something called the embedded store ingester. So I'm now going to give options to this specifically, and I'm going to say, use my PG vector store embedding model. And by the way, I don't want you to use that default thing you did. I want you to actually use something called the document by word splitter. Each size of that word should not be more than 5 characters, and they should not overlap, right? So let's see what that actually means, because that can be super dangerous. So what I'll do in the meanwhile is I'm just going to quickly delete my embedding so I don't have any conflict. Just give me a second. And the embeddings will come up again. So what I want to show you the embedding. So yeah, okay, perfect. And okay, not perfect. Come on, let's do this. One document parsed, yes. So here you see the embeddings. Look at the text. Do you see the text on the left here? Right? Before it was like this whole chunk, and now it actually splits it into these 5 characters. Now if I go to my awesome JakartaEE agent again and say, hey guys, do you know who this AI Alex guy was? Who is AI Alex? AI Alex is an artificial intelligence entity named Alex. Do you think that was what was in the document? No, right? So let's take a look at the document. So where's the document? Yeah, so where's my friend AI Alex? Yeah, trying to replace himself with AI. So when we make this splitting, it will make a difference. Now the question would be, and obviously in respect of time, yeah, 2 minutes, awesome. So in the respect of time, what I'll explain a bit is that let's say you had short codes for an application, or it only has 10 characters of a product, etc., or the way your data is. So you really need to decide how your data is going to be chunked. Why do you want to decide how your data is going to be chunked or segmented or whatever you want to call it? Is obviously the context that you send. Every time the request is sent, this is also going, the similarity is going in there as well. If I did something similar here, which I really feel like I want to do, but okay. But for example, if I in my bean here actually said there's an overlap of, let's say 5 here, right? And something like 50. This is going to change things because now this overlap means that it's also able to find similar matches within the same embedding as well. So AI Alex will not just be doing stuff like AI. Actually, AI Alex will end up doing more things than just replacing himself with the AI, right? And that's the, sorry, just gonna do that quickly before it actually loads. Let's see. Okay, it's coming. So what I want you to take away from this very 10 minute of confusion is that basically,
so sorry about that.
The documents that you split, you have to decide how you want to split them. You can split them by a sentence. You can split them by a word. You can take chunks of parts of your document. You can do regular expressions on them, etc. And the reason you want to do it is because you want to get the right similarity search. You want to get the right result out of your similarity search. So now, yeah, thank you. So now this is a bit bigger. It's still not big enough for the context that we have, but what is big anyways? So I'm going to say, who is AI Alex? And, so it says AI Alex is a 30-year-old individual who's trying to replace the architect and codes in Java using Vim. And that's not true. We know that, right? So the default premise is, in my view, respectfully, large language models are always at the edge of lying, or they're lying, right? And that's how we should develop with large language models. And all these different tools and contexts that we have, especially with LangChain4j, we are making sure that we have the right prompts, we have the right segmentation, etc., to get the data that we need to. So I'm just going to stop here since the time is up, and we have some links here which feel free to follow and connect with us. And if you want more about this demo, I'll be outside. We'll both be outside. We can answer questions. Yes, someone had a question. Someone raised their hand.
I was just going to say, what is the scaffolding that's provided by JakartaEE specific to this, or was all of the AI-related stuff provided by the chain for Java? So
the reason we chose JakartaEE, like we mentioned a little this earlier as well, is just to show you how LangChain4j under the hood works, right? Basically how you're going to wire things up, etc. If you were looking at annotations, etc., you could go for Quarkus. Quarkus does LangChain4j. I believe Halidon also does that. There's also an effort in JakartaEE, which is around a small RAI LLM effort, which will also have some scaffolding, etc., on top of it as well.
So the annotations pieces that you're showing, like the app tool annotation?
That's part of this, but there's more nice scaffolding stuff on these other frameworks.
Okay.
Cool. Thank you very much.